lecture we had seen how a perceptron can be used for a binary classification problem. In this lecture we will see a single neuron model called a linear unit, which can be used for solving regression problems. So linear unit is the simplest form of artificial neural network with a single artificial neuron which has an identity activation function. It can be used for solving linear regression problem. So what it does is it takes n inputs, some x1, x2, so on, xn, and it gives some real value as an output. That real value output is simply weighted sum. That is in the form w0 plus w1 x1 plus w2 x2, so on up to wn xn. So which is similar to our linear regression problem. So given a data set, finding those w0 to wn values is a learning problem. Can be solved by using a gradient descent algorithm. So here we are considering a cost function as a sum squared error. So suppose there are m training examples. Error is the output of a neuron, that is y cap, minus the actual output that is required is t. So yi minus t gives the error, sum over squared error over all training examples we are considering. And as we know that in case of gradient descent, you update the weights in the opposite direction of the gradients. So where the gradient is the derivative of this EW with respect to WJ, and you are going to use eta as a learning rate. So here WJ is WJ minus eta into in the gradient. Now if you calculate this gradient, so this 1 by 2 term is used to cancel out the 2 that you get in the derivative. So if you cancel out, then you get y cap minus ti into xj. This I is representing the ith training example. This is in the form x square, so x square 2x into dou x by dou wi. So as we know that y cap is w0 plus w1 x1 plus so on wi xi. So you are doing with respect to wj, all the remaining w's are independent, so you will get xj, the term that is multiplied with wj. Now this is the partial derivative, so if you substitute, you are going to get this update rule. So that is wj is wj minus eta into sigma I is equal to 1 to n y cap minus ti into xj of I. and this we need to repeat until we get the convergence. And this, so as you have observed here, we have considered all training examples and then we have updated the weight. And there is another mode of gradient descent, that is incremental mode, where after every training example you update the weights. So for one training example you calculate what is the error, that is y cap minus t, and then you take the squares. Again we are using 1 by 2 to cancel out the derivative. To update the weight, again we will move in the opposite direction of the gradient, that is dou by dou wj into EW. So if you update the weights by taking this gradient, so the gradient derivative, that is 1 by 2 into x square, so it's in the form of x square, so 2x, again derivative of y cap, that is you are going to get xj, because t is constant, so it will cancel out. So if you substitute, we will get this this update rule, which is similar to the update rule that we got for a classification, that is wj is wj minus eta into error into xj. This is how one can use a single neuron for solving linear regression problems. Now as we had discussed already, the perceptron can only be used for the binary classification problem, as well as when it is linearly separable. Now when it is not linearly separable, you consider a simple example of XOR, learning a Boolean function XOR, where you have two inputs x1 and x2. Whenever you have even number of ones, you are going to get 0. Whenever you have odd number of ones, you are going to get 1. So for 0 0 0 1 0 1 0 1 1 and 1 1 0. So out of 4 data points, 2 data points 1 0 0 1 belongs to positive class and 0 0 1 1 belongs to negative class. If you show it in the graph, like this 0 0 point, we are using dot for representing negative class. 0 0 and 1 1 are dot, and 0 1 1 0 we are using plus for representing. Now as you can see here, it's not possible to draw a single line to separate these two classes. If you draw a line here, only this point belongs to one class and these three belongs to another class. If you draw a single line here, only this point belongs to this class and all the remaining 3 points belongs to another class. So it's not possible to draw a single line to separate these two classes. It's not a linearly separable pattern. When you have such a thing, we cannot use perceptron, or perceptron fails in this case. Then what should we use? We have to use a multi-layer network. So that's what we will be discussing in the next class. That is how to solve this XOR problem by using multi-layer network. Thank you.